Hi everyone. We want to study our implementation of regression tree. So you can see the concept video for section 8.1.1 if you forget the contents. Okay, first we want to review the data. So we are using car seats data in library ISLR, and we are using tree function for regression tree. For some visualization purpose, we use the correlation plot CORR plot package or CORR plot function. So now we want to see the data first. So what's the car seats data? So car seats data have 400 observations of 11 variables. And this is basically the sales data of the child car seats by 400 different locations. And we have 10 predictors: the competitor's price and income level in the neighborhood, and advertising amount, the population of the neighborhood, price, and the shelf location in the store, the age in the area, education level in the area, and the urban or not, and the US product or not. So we have several variables. So for visualization, you can of course use the pairs function to make pairwise plot. We have 11 variables, so it may be too many to get just one pairwise scatter plot. So car seats, maybe we use just first 6 variables. Then you can see that the sales, competitors' price, income, advertisement, population, and the price. So you can hardly see the relationship between sales and other variables. Price is actually negatively correlated with sales. That's natural. And maybe we have some relationship between advertising amount and the sales. How about other predictors? So first one is response variable, sales. So we keep it, and we make scatter plots for other predictors. So this is sales, shelf location. So actually the 1 is bad, 2 is good, 3 is medium. So actually the shelf location matters a lot. So maybe if we change the order, it's better correlation. And age also affects the sales. Educational level, maybe. And other two, it's binary, so maybe we need a table to see. So yeah, so pairs function, but also I introduced another good illustration of the data. So that is correlation plot function. So at first we want to, so we want to make the correlation kind of heat map. So we at first have to transform these factor variables to numeric first. So at first, we change the order of these 3 categories. The bad, good, medium is not the correct order. So bad, medium, good is better. So we at first change the order of these 3. We can use the levels function, levels option in factor function to change the order. The default is in alphabetical order, so we change it in this order, into this order. Then also we want to make factor to numeric. So in this way, the levels are bad, medium, good. So this is 1, 2, 3. So it becomes 1, 2, 3. So you can see maybe head of car seats, shelf location, then you can get 1, 3. This is actually the bad, good, medium, medium, bad, bad. So that is a correct order. And also the urban and the US are factor variables, so we make it the numeric. So for example, urban becomes vector of 1, 2. So no is 1, 0, no is 1, and yes is 2. So in this way, we make the data set with all numeric variables. So we can use this correlation function, correlation plot function, and we can include the correlation matrix. Maybe we can just type correlation matrix first, the car seats. Then you can make this correlation matrix. So you can see all correlations. So sales and other variables, you can see correlation of 0.06 or 0.15, 0.27. This may be good. So and so on. But this isn't really the graphical. So we can use correlation plot function of this. Then you can see a plot. So this is more informative if you don't have much time. So of course diagonal term are all 1. The correlation of sales and the sales is 1. And these blue circles are higher the positive correlation. The red circles are negative correlation. So sales has negative correlation with price. That's natural. Positive correlation with shelf location, and age maybe some negative correlation, and so on. So yeah, also if you see the correlation coefficient, you can specify the option method is equal to number. Then you can get numbers. Actually, the smaller number, if numbers are close to 0, it's really the light color, so we cannot really see well, but you can see larger correlations here and here. Maybe here also, but we are interested in sales, so maybe these correlations are most important. So you can see, you can search for packages which can generate the fancy figures. So it's useful for final presentation. Okay, so now only we described the data, but in the next video that we do regression tree. Okay, see you then.